Okay, we were talking about, oh, not partial. No, next page, page 60. Okay, 48, yes. 60 is where we are at in physical science.
Mr. Chance, will you keep us on our toes?
Good. See this? I have a notebook here that says page 60. So page 48.
Which is pre-calculus.
So you claim.
4.
So we're going to look at, just first we're going to review the basic one, and then we're going to look at some of the more complex ones. They're a bit different. So what's the first thing we do for this? Factor. What is factor? Okay, then what?
A over plus B over X.
Yeah, and then what? Okay, common denominator, x minus 5, x plus 4, x plus 4. Then we have x plus 13 equals ax plus bx minus 5a plus 4b.
Wait, can you say what you did first?
Okay, I distributed the a, distributed the b, and set it equals the top over here. And just group the a's into the x parts and the constant parts together. Okay, so now what's the equation I have to write? That's a plus b equals 1. And that's just doing the a, the b, and the coefficients. And the other one? And 5a plus 4b equals 13.
Oh, I wrote 13 now.
That's this part, and that one. Yeah, then what? Next. Yeah, you could take answers. It's just no. It was A and B would be in opposite locations, so A and B would be different numbers. But when you add them, remember you're adding here, it doesn't matter. Okay, so what do I do to solve this? Yeah, multiply by 5. You get 5a plus 5b equals 5.
Are you trying to eliminate the A?
Yeah, I just decided to do that one. So I get 9b equals 18, b equals 2, therefore a equals -1. So then our answer, -1 over x plus 4 plus 2 over x minus 5. Their whole process seems familiar from yesterday? Okay, so we're going to look at a couple more of the more difficult cases. Okay, then you can do our homework then. Okay, so one like this. Remember we started, the first example I did yesterday started off with something like that and I simplified it a little bit. This is an improper fraction because the top has the same power as the bottom. So if the top is the same or bigger, then we're going to have to use a different method, slightly different. So it's one like that. The first thing we have to do is do the division, which is going to be long division.
No.
Yes.
No.
There's x squared plus 2x. Divide by 3x squared plus 12x plus 2. Remember this?
No.
Okay, x squared raised to multiply to get 3x squared. 3. Okay, and multiply that 3x squared plus 6x. Subtract. It's 3x squared there. So get 6x plus 4. Okay? Since we didn't have any x's here, and there's nothing we can multiply x squared by to get here, we're going to go 3 plus 6x plus 4 over x squared plus 2x.
Wait, why did we have x plus 4 again?
Okay, we subtract right here, so we're just subtracting them.
No.
Was that a question, or
No.
where that came from, or what?
Yeah. Well,
Okay.
well, why did we, how did we get from 6x plus 4 to 3 plus
We did 12x minus, or we did 3x squared minus 3x squared is 0. 12x minus 6x. 4 minus nothing.
4?
We get 6x plus 4. In order when you do division, you just put the whatever you have left over, or remainder, over what we started with here. Yeah. Yeah. Then we're going to take this side and treat it like we did before. So what do you first? Factor. So x plus 2. So now, notice this 3 is going to hang around clear to the end, but I'm going to ignore it for right now. The 3 is not going to affect the rest of the problem. And in the answer, we get the end. So I'm going to go down here and say 3 plus whatever. Okay, and so now it's going to be separated. You have to put the 3 in here, and then just we can subtract out the 3 when we're solving. Let's check with here.
X.
And here.
X plus 2.
Up here. Okay, and then what would you do?
Combine. Common denominator.
Okay, so there's now an x plus 2 x. So we have 6x plus 4 equals ax plus bx plus 2a. So then what is the equation that can write? A plus b equals 6 and
2 equals 4.
2a equals 4. Therefore, what's a?
B.
2, and what's b?
And 2. No, 4.
Okay, so my answer is going to be 3 plus 2 over x plus 4 over x plus 2.
Harder to take that.
No, it's harder. Like to where?
Because 2 times 2 equals 4.
X squared plus 3x.
Where are you talking about?
The original problem 3x squared plus 12x plus 4 divided by x squared plus 2x.
Yeah, that's here. Okay. Okay, everybody with me on that? So, let's do a bit more difficult one. X plus 2 over x cubed minus 2x squared plus x. What do we do first? Factor, okay, so x squared minus 2x plus 1. Can't factor further. Okay, what would this factor as? X minus 1, x minus 1, or x minus 1 squared. So, this is going to be one where if we have a repeat, meaning I've got 2 things instead of just 1 of the same. So if I had x squared here, we'd have to do the same. Instead of just 1 part, we're going to have 2 parts, or 3 parts. So we're going to say a over x plus b over x minus 1 plus c over x minus 1 squared. What? Okay, because anytime we have something that has a repeated solution, like this, x minus 1 is there twice. We have to have every factor of it. So we have, basically we have x minus 1, and then here x minus 1 squared. So if we have the same thing, we have, say, x cubed times x plus 5. On the bottom, we have a over x plus b over x squared plus c over x cubed plus d over x plus 5. We have to have every power up to this point represented. But from here, we're going to treat it basically the same. We've got 3 variables. What do we do? Common denominator. So this is going to multiply by x minus 1 squared. This one we're going to multiply by x and x minus 1 and x and multiply by x here. No. We only have an x here, and we need to get an x minus 1 squared. We want to have the same denominator as we had over here. We already had an x, but we need an x minus 1 squared with it. So then here, let's see, we have x plus 2 equals a times x squared plus 2x or minus 2x plus 1. I'm just spoiling this out. Plus b times x squared minus x plus bx. Okay, anybody stuck on that?
Why didn't you skip this?
Oh, just didn't want to do it yet. I was skipping a couple steps here. I just skipped one step. So I have x plus 2 equals ax squared minus 2ax, or 2x a plus a plus bx squared minus bx plus cx. So now we've got 3 variables, 3 unknowns. We have to have 3 equations. So a plus b equals 0. That's going that one and that one. Okay, next one. 2. So that's negative 2x there equals what? 1 and a equals 2. Guess that made the last one easy. So if a equals 2, then what is b? B equals negative 2. Okay, and then what is c? Let's see, we have negative 4 minus plus 2 plus 1. Or plus c plus 1. That's 3. No. Okay, everybody with me on what we did? And then, of course, I'm not going to do anything right after the last step. Or is everybody with me? Okay. We just plug this into what we had up above here. This one is the more challenging one. We have x cubed plus 2x over x squared plus 1 squared. So how is this different from the other? Okay, because we have the quadratic term down here. We have an x squared. And notice, we can't factor this any further using just a rational number. Can't factor the bottom further. This is where when you run into a problem like this where you can't capture the bottom further using just rational numbers, but still have a quadratic, meaning you have squares down there. Then we're going to have to make it a bit more challenging. Okay, we're going to have ax plus b over. Okay, so if we have a squared here on the bottom, so if you look back here, we had x minus 1 squared. If we have a squared here, when we factored it, we're going to leave a squared, or we have to have the ax on top, plus here, bx plus d over x squared plus 1 squared. So remember, this is just like the last one where we had a squared term and a regular term.
I remember the numerators.
The numerators? Okay, so anytime you have a quadratic term once you're factored in the denominator, we have to have a linear up here, meaning ax plus b. So if we had, say we factored and we got x cubed plus 5x or something like that, plus 2 in the denominator, we would have to have an ax squared, or ax squared plus bx plus c in the numerator. So depending on what we have in the denominator, it changes what we have in the numerator. So depending on what the factored form, if our factored form includes a squared, in the numerator we're going to have a linear, an x. If we had a cube here, in this term we'd have to have a squared. Okay, so beyond this we're going to treat it the same way. Get a common denominator. So what do we have to multiply this side by?
X squared plus 1 squared.
Okay, x squared plus 1, how about? Then have x squared plus 1. So up here, x squared plus 1. What about this one? Nothing, because it already has the term. So I'm going to have x cubed plus 2x equals, let's multiply this out, ax cubed plus ax plus bx squared plus b plus cx plus d. Okay, how many variables do we have? 4. So how many equations are we going to need? 4. Let's start. First one. A equals 1. Okay. And that's going from ax squared, or x cubed, I mean x cubed.
B equals 0.
Okay? B equals 0. So that's here and here.
A plus
Because there's no squares over here. Okay?
plus B equals 2.
Okay? A plus C equals 2. So that's this one, there.
B plus C is 0.
Okay, what was that? B plus D equals 0. That's B, D, and our other one. Okay? So, A equals 1, B equals 0, C equals 1, D equals 0. So our equation, so B equals 0, so it's going to be x over x squared plus 1 plus C is 1, so x over x squared plus 1 squared.
And that's the final answer.
Yeah.
What if B is 1?
Okay, if B is in 1, we have x plus 1. Let's see.
What if A is 0? Then would it just be 1?
Then you just have the B. If it wasn't squared here, like if this was just x plus 1?
X squared, no, if it was x plus 1 instead of x plus 1, x squared plus 1 squared.
Are you talking over here?
Yeah.
If it was just x plus 1 squared?
X squared plus 1.
So okay. X squared plus 1. Then because we can't factor it, there's nothing else we won't be able to do anything. Yes. Let's see. Do another one of these. 4x cubed minus 7x over x squared plus x plus 1 squared. What should we do? First question is this improper?
Yes.
What's the power on top? 3. What's the power on the bottom? 4. So not improper. You see where the 4 is coming from in the denominator. So if I multiplied this out, I have x to the 4th. That's why we know it's not improper. If it were improper, you'd have first have to do the long division. Yeah. Okay, so how are we going to set it up? X plus b over plus. Okay, everybody understand where that's coming from? Okay, do it. When you do it, try it out. X squared plus x plus 1. Top and bottom, so I'm going to have ax plus b times x squared plus x plus 1. Plus, what am I going to multiply this by? Nothing, okay. So cx plus b equals 4x cubed minus 7x. Okay, so this, lots of experience with it, right, everybody? What, so, we have ax cubed plus ax squared plus ax plus x squared plus bx plus b plus x plus b equals 4x cubed minus 7x. Okay, so first equation, a equals 4. Not convenient.
A plus b equals 0.
A plus b equals 0.
A plus b plus c.
So this, mark off the ones we've done. So x squared, x. Take care of that one. A plus b equals negative 7. So it's a, b, c, negative 7.
A plus b equals 0.
B plus b equals 0. So a equals 4, b equals negative 4, so plugging that in here. C equals negative 7. B would equal 4. Okay, what? Square cubed minus 7x. Well, the negative 7 we took into account right here. Are you talking right here?
Yeah.
Okay. Because we have plus up here.
Because
We're just saying we are adding two things together. Yeah. For example, if we put a minus here, it would just make these two negative or whatever they were before. So it doesn't make a big difference. But all our goal is saying we can combine these by addition or subtraction, and we just assume it's addition to start with to be easier. Does that make sense? Okay.
Is this the part of it again?
Pretty much, yeah.
Oh,